Good morning, students. Last class we have been discussed the derivatives of exponential functions and logarithmic functions. So today I am going to discuss what logarithmic differentiation. So logarithmic differentiation is not a derivative of logarithmic functions. So both are different from one to another. Derivatives of logarithmic function means we need to differentiate log functions. So logarithmic differentiation is a method of differentiation to use sum of the functions to find its derivatives. So let us observe what is meant by this logarithmic differentiation and when we use the logarithmic differentiation and how we use the logarithmic differentiation. To understand this, I am going to consider some three examples. So you observe here, the first question is find dy by dx for the function y is equals to 2x plus 1 power 3. So to differentiate this function, we have a chain rule. So by using chain rule, we can differentiate this function. And suppose y is equals to 2 power x is one of the function. And to differentiate this function, we have what? The formula for derivatives of exponential functions. So by using derivatives of exponential functions, we can easily differentiate this function. And if the question is of the form y is equals to x power x. Now observe here in the first question, the function is of the form variable power constant. So in the second question is constant power variable. But in the third question, observe here, variable power variable is exist. So to differentiate variable power constant, we have chain rule. Or to differentiate constant power variable, we have the formula for exponential functions. But to differentiate the functions are of the form variable power variable, we don't have any derivative formula. So that's why to differentiate the functions of the form variable power variable, we use what? Logarithmic differentiation. So I hope all of you understood. When we use the logarithmic differentiation, if the function is of the form variable power variable. Now let us understand how do we use this logarithmic differentiation. So by considering one of the example, I am going to show you how we use the logarithmic differentiation. So let us consider this example only. Find dy by dx. Find dy by dx for the function y is equals to x power x. For the function y is equals to x power x. So when we are going to differentiate using the logarithmic differentiation, the first step is taking log on both sides. Taking log on both sides. So then the question becomes what? Log y is equals to log of x power x. Now observe the term on right side. It is of the form log m power n form. So the property of this log says that log m power n is equals to n log m. Therefore, by using this property, log y is equals to x into log x. So x goes on the multiplication with log x by using this beautiful property of log. Now, observe here, we eliminated the variable power variable formula and it will be converted as a product of two functions. And in derivatives, we have a beautiful formula to find the differentiation of product of two functions. That is what product rule. We know that product rule is u into v. So derivative of u into v is first function u as it is, derivative of second function plus second function as it is into derivative of first function. So it means here the first function is what? Here the first function u is what? X, and second function v is log x. So now what? Differentiate this with respect to x. So derivative of log of something is 1 by something into y with respect to x is dy by dx equals to, here first function x as it is into derivative of log x is 1 by x plus second function log x as it is into derivative of first function is 1. So therefore dy by dx is equals to, dy by dx is equals to, shift this y towards the right side, and in right side x and x get cancelled, remaining 1 plus log x. So therefore the final answer for dy by dx is, observe here, dy by dx is equals to, what is y in the given function? X power x into what? 1 plus log x. I hope all of you understood the procedure to find the derivatives of functions using what? Logarithmic differentiation. I hope all of you understood. Let us consider one more example to understand procedure to find the derivatives of functions are of the form variable power variable. Let us consider the second question. So find dy by dx for the function y is equals to x power cos x. So again this function is of the form variable power variable. So therefore to differentiate this we use what? Logarithmic differentiation. What is the first step? First step is taking log on both sides. Taking log on both sides. So therefore log y is equals to what? Log of x power cos x. Again by using the property of log, log m power n. Log m power n becomes what? N into log m. Here m is x, n is cos x. Now function power function is converted as a product of two functions. So we can easily differentiate this. What is the next step? Differentiate this with respect to x. So derivative of log y is 1 by y into y with respect to x is dy by dx, which is equals to first function cos x as it is into derivative of log x is 1 by x plus second function log x as it is into derivative of cos x is minus sin x. So therefore dy by dx is equals to y into cos x divided by x plus into minus. So observe here, plus into minus minus log x into what? Sin x. So final answer for the dy by dx is y. Y means what? X power cos x. X power cos x into what? Cos x divided by x minus log x into sin x. I hope all of you understood. Where do we use logarithmic differentiation instead of the functions of the form variable power variable? Let us consider some examples for such type questions. So find dy by dx, find dy by dx for the function, find dy by dx for the function if y is equals to square root of x minus 1 into x square plus 2 divided by x square plus 3x minus 5. So now observe here, the given function is of the form square root of something. So we know the formula for derivative of square root of something. So square root of something is equals to 1 divided by 2 into something into derivative of something. But here something is a big thing. To differentiate this using the chain rule, first we can easily differentiate square root of something. But to differentiate something, we need to use u by rule, and in u we use product rule. So it takes too many steps. Madak barlantala, we can also find derivative of this function using chain rule. But to find the derivative of this type of functions, the logarithmic differentiation is very useful. So see here, how do we find the derivative of this type of functions? So first thing, y can be expressed as x minus 1 into x square plus 2 divided by x square plus 3x minus 5 power 1 by 2. Now taking log on both sides, taking log on both sides. So by taking log on both sides, log y is equals to log of what? X minus 1 into x square plus 2 divided by x square plus 3x minus 5 power what? 1 by 2. So now by using the property of log y is equals to log m power n can be written as n into log m. That is 1 by 2 into log of x minus 1 into x square plus 2 divided by x square plus 3x minus 5. I hope all of you understanding. Now, by using the properties of log, we know that log m by n is equals to log m minus log n. So, therefore, by using this property, log y can be expressed as 1 by 2 into log. It is of the form log m by n. So, log m is what? X minus 1 into x square plus 4. Sorry, x square plus 2 minus log n. N is what? X square plus 3x minus 5. I hope all of you understanding. Again, we have one more property of log. If log m into n can be expressed as log m plus log n. Therefore, log y can be expressed as 1 by 2 into, so observe here, log m into n, log m, log x minus 1 into log n, log x square. Sorry, log m into n is log m plus log n. Log m plus log n. Log n is x square plus 2 minus log of x square plus 3x minus 5. Now, this big thing as converted as something, because we can easily differentiate this log x minus 1, log x square plus 2 and log of x square plus 3x minus 5. So after using log on both sides, directly we go to the second step, that is what? Differentiate this with respect to x. Differentiate this with respect to x. Now, derivative of log y, 1 by y into dy by dx equals to 1 by 2 into derivative of log x minus 1 is 1 by x minus 1 into derivative of x minus 1 is 1 plus derivative of log x square plus 2 is 1 by x square plus 2 into derivative of x square plus 2 is 2x minus Derivative of log x square plus 3x minus 5 is 1 divided by x square plus 3x minus 5 into derivative of x square is 2x plus 3x is 3. So finally dy by dx is equals to 1 by 2 into shift this y into 1 divided by x minus 1 plus 1 divided by x minus 1 plus 2x divided by x square plus 2 minus 2x plus 3 divided by x square plus 3x minus 5. So therefore final answer for dy by dx is equals to dy by dx is equals to 1 by 2 into y. What is y? Y is square root of x minus 1 into x square plus 2 divided by x square plus 3x minus 5 into 1 by x minus 1 plus 2x divided by x square plus 2 minus 2x plus 3 divided by x square plus 3x minus 5. I hope all of you understood. So logarithmic differentiation also used in the functions which can also solved by using the chain rule. But to use chain rule, this type of functions, it is very complicated. So that's why in this type of functions to find its derivative, we use what? Logarithmic differentiation. I hope all of you understood.